Hi guys, welcome in my Coding Battle channel. I am present here with new video, cache update strategies. So the first question arises when cache update strategies comes into play. So these strategies comes into play when suppose a new write request came, and so you will think where should I write first? First be I should write in the cache or should I write in the database? Or first I should write in the database or then cache and then return to the success signal to the client. Or suppose one update request came, so the same question will arise: should I update in the cache first or should I update the database first? And suppose a read request came, so you will suppose if data is present on the cache, then you will return the success, and or it is not present, you bring from the database and then put on the cache and then return to a success signal to the client, right? So you should need to implement the appropriate update strategy in the cache according to your use cases. So why appropriate cache update strategy require, right? So update strategy impact the performance a lot. So it is very necessary to choose the appropriate cache update strategy to update the cache content according to your use cases. So what are the update strategies? So update strategies are like there is four update strategies. So one is read through caching, second write through caching, third write behind caching, fourth refresh ahead caching. I will describe all those strategies in detail one by one. Uh, and second is like there is also a cache eviction policies. So the cache eviction policies comes into play when suppose your cache disk is filled and new request came. So which keys you will evict from the cache, right? So these strategies apply to the cache. And so like there is five cache eviction policies here. So like first one is first in, first out, like in a queue. And second is last in, first out, like stack. Least recently used and least frequently used and random selections. So I request you guys, please do not confuse update strategies with eviction policies. Like if eviction policy comes into play when our cache memory is filled or we need to refresh few keys, right, in the cache. And update strategies comes into play when a write request come and need to update the data in the cache and new read request came and data is not present in the cache. And the one concept is time to live. So suppose what happens sometimes you put the data in the cache, but there is no update request came for that particular keys or no any further read request came to read that keys. So it is very necessary to expire those keys and update the cache regularly so that new case will come. So time to live is a time period that states a particular key in the cache will be active. Like suppose any key we insert the keys in the cache and let's our like time to live time is like 1 day. So that key, all those key that is present in the cache will be active for the 1 day and it will be expired in the next day. So this property is configurable. You can configure it. So I have put some examples like Spring Boot with Redis. So you can configure this property like 1 day, 5 minutes, 10 seconds. So according to your use cases, you can configure this one property. Now I will discuss all those update strategies in detail. So, but in this video, I will explain the strategies, but I will not tell you what are the advantages and disadvantages. I will cover those advantages and disadvantages details in the next video. So, like first strategy is like read through cache, right? Read through caching. So, what you can say in this strategy, what happens? Suppose a client make a request. This is client. You can say client make request, and the request go to the API servers. So first, if the that key is present on the cache, like that requested data is present on the cache, then it will return to the success to the client. If it is not present in the cache, so it will go to the database and then bring that data from database and put on the cache, and then API server will return to the response to the client, right? So in this way, this read through caching work. Second strategy is second update strategy is write through caching. In this strategy, what happens? Suppose any request came to API server, any write request came to the API server. So that server will update the data first in cache if it is present, and then that a transaction goes to the database and it updates the data on the database, and then return back to the API server and return API server will return the success signal to the client. So in this strategy, what happens? There is a like always first you will not return the success return until the data is written in the cache as well as the database, right? So because so this strategy it is time consuming. So like what happens? Transaction came and first it will write the cache and the database, and the writing to the database is it took a lot more time as compared to the cache, right? Writing in the cache. So but according to some use cases you need to follow it. So and the third strategy is third one is right behind caching. So what happens is right behind caching, any write request came to the API server, suppose. So what happens? It will write the all the data in the cache and return to the success signal to the client. Uh, so it is like more faster because it is not writing in the database, right? It's only writing in the cache. And after a regular interval after a regular interval, asynchronously the data is data written to the database after every regular interval of time. So and that transactions we need to whenever any update happens in a database, you need to update all those database in that sequence that all the write requests came in your system, right? So what happens? It uses the queue to know the sequence of the update function or write function that is write request that is coming on it. So every time it only whenever a request came, it updates the data in the cache and return to the success signal to the client. And then after a regular interval time, it updates in asynchronous job is running. It updates the database. So it is in the perspective of the user's experience, it is more faster because every time whenever a request came, we are only writing in the cache. So it is writing in the cache is faster than the database. So it is more like you can say more faster than another caching strategies. So, but what happens? There is also a drawback. Suppose you have write the data on the cache, and the before updating that data to the database, the cache is crashed. So all those I will cover on the in the next video. How it handle the crash if the cache is like crash somehow. So yeah, and the fourth. Let now go to the fourth strategy. So fourth one is write ahead caching. So yeah. Fourth one is refresh behind ahead caching. So in this strategy, what happens? In this strategy, what happens? Suppose we have the keys on the cache, and it is like a read heavy cache. Suppose some keys are about to expire, right? The TTL time is coming near reaching. So what will do? A job is running, so that will automatically refreshes all those keys that are about to expire in the cache from the database, so that whenever a read request came for the data that is present on the cache, you will not load to again from the database. So because in the if this will not happen, so suppose what happens, you have one your some keys present on the cache, and it is like TTL time is 1 day, but that day no any request came, and and it is about to expire keys on the cache. So if you will not refresh the cache in after 1 day, so what happens? Suppose same request came from next day, so it will take time because you will fetch the data from the database and then put on the cache. So it is so this strategy will not you will help to avoid the reloading at the time of request. So in this strategy, you in the regular interval of time when whenever some key is present on the cache is about to expire or reaching to the TTL time period, so you will a job automatically will refresh the those keys in the cache from the database. So that's it, guide for this video. Please like and subscribe and share video if you like it. Thank you.